And we are live.
Thank
Hello
you.
everyone.
Hello,
Hello,
hello.
Mary.
Too. Yes, thank you. Thank you, Louis, for hosting me. And thank you for those of you who are live right now or even like on demand afterwards in the future. Thank you.
Yeah, I'll give you an idea. If you are here watching us live, tell us about yourself. Tell at least from where you are.
Hmm.
Put in the chat. So, hello everyone. Thanks for joining us on the second day of the J Champions Conference 2026.
Thank you.
Yeah, I'm Luis Real, and I'll be moderating here this session. And I have to say, it's an honor for me to be
Oh,
hosting Mary. Yeah.
thank you.
So
Thank you,
yeah.
Louis. Thank you.
And beyond being a Java champion, she is the president of CJUG, the Chicago Java User Group,
Thank you.
and also VP of Global Western Hemisphere and member of the leadership team for the AI Collective,
Oh, thank
that
you.
is the world's largest AI community, where I also have the pleasure of volunteering. So thank you so
Thank
much,
you.
Mary,
Thank
for that.
you. Thank you.
So without further ado,
Mhm.
here to talk about harnessing event-driven and multi-agent architectures for complex workflows in generative AI system. Please help me welcome her to the stage of the J Champions Conference. Mary, the stage is all yours.
Thank you. Thank you so much, Louis. Thank you again to everyone for taking your time and coming out, to see me. So thank you for from wherever you are. So yes, so my talk. Let's see. I'll put it onto the screen, right? Yeah. Thank you, Louis. Yep. So yeah. So folks, yeah, and I normally if I do this talk, and I've been doing it for about a year or so, and but it's kind of interesting, as we all know, generative AI is changing rapidly too. And the definition of agents also are not all fixed, as we all know. It's very interesting, like how the business, the marketplace is looking at agents. It's a bit different, I think, than what I'm going to talk about here, because I'm really starting to tap into this a bit deeper, right? I like to, for example, I kind of suddenly thought of this. I like to think of the way the agents are. I use this analogy of driving a car. A lot of people, I'm sure, right, when we drive, or even most of us, when we drive a car, we don't care about how the engine is all working, like essentially underneath the hood, how it all works and what does it mean, all these. We just want to get to places. And whatever is being sold, right, by the salesman, they talk about something else rather than underneath the hood. But the thing is too is there are lots of things to me, right? This whole AI, actually particularly generative AI revolution too, that's happening. They are obviously kind of focusing on what it can be done. All these things can be done quickly. All fine, all good, and that's what we should be doing. But I think as builders here, like Java J Champions, we're attracting Java developers, builders, all of these. We care more too deeply about how things work underneath the hood. It's very important. So that's when I also start to think that agents, while we're talking about it in the marketplace, to me is a bit more shallow, the type of usages, because we know that in IT shops we're dealing with much larger issues sometimes, right? Like trading firms, how do we time some transactions, how do we deal with distributed data? So this is actually what I'm going to explore into leveraging event-driven, multi-agentic type of architectures for these complex workflows in Gen AI type of systems. So thank you. I won't go into all the details explaining myself, because Louis already did a good job. So let me kind of real quickly though give you a kind of quick run through of my agenda. So just a quick introduction about myself, and then talk about demystifying this Gen AI and agentic architecture, and also bring in the event-driven world and AI. So I'm kind of saying that really, because the thing is, I'm not seeing too many talks, so to speak, right, across the board, that people explicitly start to tap into, how do we deal with concurrency? How do we deal with distributed data? All of the problems, they haven't gone away. Not only that, I have yet to see an agent able to generate code that handles complex, like threading, concurrency, all of these things, right, that actually are solving some kind of the world kind of more kind of complex problem. So I just want to get a bit then into distributed computing and agentic AI. And then also talk a bit about RAG and also like, where actually event driven things is happening, like that. So, and then I'll bring up some challenges of Gen AI. And essentially, this talk, I have to admit, I won't have too much code at this point, but I'll share with you my stream to. So then you can join me, right? Like I'm doing Twitch stream or YouTube stream. I have yet to commit my time again, so to do that. So without further ado, I know the time is short, so I won't say too much about that. But just wanting to give a bit of a prologue, right, to the rationale behind my talk and all of these things. So so here's just a picture worth 1,000 words. That's me. So I'm a Java champion, obviously, and also very honored to become an Oracle ACE associate 2 months ago. I'm actually deep in my heart, I'm a passionate advocate, still speaking a lot. And these days, as Louis mentioned, I'm helping AI Collective. Is the world's largest. It's a grassroots organization. So I also invite you, if you are interested. It's not so much about what programming tools, all of these things. It's really more about the, how do we build AI. Also, there are investments and all of these things. So all kinds, it's different aspects. So if you're interested. So yes, I'm very interested in applying all of these tools, these techniques out there to solve some real life complex problems. So that's me. So let me start now after like 5 minutes of talking all these things. So, okay, demystifying Gen AI and agentic architecture. Let me kind of come into right away, right? Talk about this a bit higher level kind of thing. So AI, as we all know, encompasses this whole branch of things, right? What is it, right? It's basically about automation. Ultimately, it's really having machines doing things and not only just doing what we tell it to, but it can do it autonomously. And then the thing is leverages on machine learning, unsupervised training or supervised training, and reinforcement learning. Those are the three major techniques around it. But the thing is, what really makes things happen is really the deeper, much deeper, deep learning neural networks. And that's actually where a lot of research and where LLM is happening. So on the right side, where generative AI is happening. Now, AI just all of a sudden being brought to the foreground because it has become more accessible by a lot of people, right? And it's just basically, you little children on your phone, you already get, different, access to different AI interaction. And these are Gen AI. Gen AI is also particularly kind of attracting attention. And I think is because for longest time, when we are coding, dealing with machines, we started off with machine language, assembly languages, and then into all of these languages that we can actually use, say Java, kind of. I think they call it, used to be right for some reason, the time I came out of school, they are still talking about third generation language, fourth generation language, that type of stuff. So it's sort of like that point. But those in the older days, right, when the languages come out, we have to talk like the machines. As we all know, we need to essentially send commands out in a very strict way. So otherwise, two machines won't understand. So here comes generative AI that comes in, changes everything because of NLP, natural language processing, as we all know. So we can interact in a naturally spoken format, very human centered and all of these things. And then, of course, it relies too on the LLM, large language models, all of these, making use of neural networking, all of these things. Now, the thing is, though, I'm finding, right? Also, too, it seems to be a lot of developers, or especially I find in the Java community, we don't like to tend to be attracted to data kind of aspect. Yet, in this AI world, data is at the center of things. So that's why I kind of highlighted here. So this particular talk is mainly about data, handling data techniques and event streaming, multi-agentic, all of these things. And as we all know, this is just a diagram describing now, we're like a lot of people are actually using AI, but we are here, we're a producer of these things. We're building AI applications, training models, and then having the data that we're working with. And that's what it turns out, all the creative ideas coming out of that. So without kind of getting all the details, everybody already are familiar with some of these models that are out there, so I won't repeat. But out of that, of course, OpenAI came out first, and there's GenAI or GPT that came out right to little, well, actually 3 years. I cannot believe 2022 November. So now we're 2026. Pretty amazing. All of these things that are popping up, but I think it's also like confusing the market a lot too. And then there are also generative platforms to AI platforms, I should say, generative AI platforms, apps, and just want to highlight too. There are also like companies that find it is quicker to develop using some kind of AI that's optimized type of platform. Now these are just a little handful. Amazon SageMaker, the major hyperscalers, Amazon AWS and Azure and Google Cloud, all of these things. And I was just going to say, because with my AI collective, we also have, for example, like Vercel is a JavaScript platform, right? Nix.js, if some of you may be familiar with. They also have what they call like a new platform called V0 too. So that kind of optimized for doing AI and is easily deployable cloud type of platform. So the market is full of kind of exciting things. But let's kind of refocus back now. Let's step things up a little bit, right? So beyond all the hype, all of the LLMs and all of these things, and it's basically LLM, as we all know. And why agents, right? It's because LLMs, as seemingly powerful it is, right? It's a crunch all the data that you feed into it, and of course it's not cheap, right? Making use, it needs a lot of GPU power. It's still an energy hog, all of these things. But the thing is too, ultimately LLM has its own limitations too. There's no memory in itself, right? It's just basically what you feed it in. It knows what, it does magic. And of course, it's superhuman speed that does things super fast, and also like analyze patterns, all of these things, right? And that's what it is good at. And that's where I feel we can leverage it, right? Especially developers or not developers, whoever is using LLMs. But by itself, it's kind of limited too. It can't, you can't actually add attributes to the answers. The results too are probabilistic, meaning that the algorithms are all non-deterministic. So, and that's where I think is kind of like a point in which all a lot of business are not quite ready and people are skeptical. It's because of this probabilistic nature of it. You ask the same question a million times, it will come back with not exactly the same. However, we know that as developers, engineers, we are talking about precision. We're talking about exact. So if things can't be exact, it's harder to be accepted. Now, not to say it's useless, but it's just that maybe LLMs are more suited to certain types of applications, or maybe the way we build it ought to be. So then, we can avoid issue with having to deal with exact type of things. But all these things we need to think about. Now, the thing is too is for a lot of businesses, they also have
Hello, I think we had some issue here. Just a second. Sorry, guys, we have an issue here with internet connection for Mary. Just wait a second and I'll see if she can come back here. Yeah, that's good. I can tell a few jokes. No, sorry. Sorry, Francois. Okay, I'm talking to Mary. I think she can't get here again. Just a second.
Okay, sorry about that. I think I'm back here. Okay, I think also could be because it's been very cold where I am. I don't know whether it's affecting the internet connection, so I apologize for that. Let me share again my screen. Okay, all right. Can you see now? Oh, sorry, sorry, folks.
Yeah,
Okay, thank
everything's
you.
set up now.
Yeah, okay. So I'm using my cell hotspot, so it should be okay. My for 5G or 4G, I'm actually not quite 5G, but thank you. Okay, let me resume. I'm sorry I wasted a couple minutes of you guys. Okay, I was talking about LLM, and thank you so much too. I think Johan and everybody is being so forgiving. Okay, so I just basically want to go back talking about LLM and why we get into agents, right? It's because of LLM's limitations, and we know it's like this big crunching things, but it's not very flexible, right? So all the stuff, as we all know, computing, we're dealing with a lot of connections and how do data flow and how all of these glue get happens, and that's when agents come in, because for developers like ourselves, we are dealing with enterprise kind of level of applications that we have to handle non-functional aspect of a system, for example, like scalability, concurrency, workflows, and complex like data flowing. And also, not only that, there are distributed data that we have sources being hosted on different nodes and things like that. So all these things, I really don't think, and people, you can tell me too in the audience, right? Has there been actually agents that can handle this level of complexity, right? Not, I'm not saying that's the only kind of application, but and as we all know, a lot of the world's kind of more complex enterprise apps is really require that level of complexity. So that's what this talk is kind of, I'm hoping to achieve, is we start to kind of dig into these deeper level of things that we need to handle. Can we do it from using complex event driven multi-agentic architecture? So that's what it is. Okay, let me go. So let me kind of go to the next page. So now that kind of brings into like agentic architecture. So the structure and design of AI systems that leverages on AI agents to perform tasks, right? So it needs to these agents needs to be able to execute on tasks like autonomously too. So autonomous meaning that that's where perhaps too is where the LLM could come into play. That an agent still needs to do the legwork of connecting things, but basically the bulk of that compute could be kind of delegated to LLM to do it, to kind of figure things out essentially. But of course, at this stage, we are not at AGI yet, which is artificial general intelligence. I think the thing is too, it's actually funny talking about AGI. If you've been paying attention, right, to all of these things that came out 2 days ago, I saw somebody that says, "Oh, OpenAI finally came out with AGI," but what it means is actually, I think, advertised generated income. So it's like about their marketing thing that they can do like ads and stuff like that, rather than meaning artificial general intelligence. So anyway, but that's just what I'm trying to refer to. And also to not only that, right, not a single tool and agent can do everything. So the thing is, it relies to on a lot of different tools and third party integrations, all of that thing. So we need to have agents also being able to handle that. And then of course there are also the scalability aspect, as I mentioned about too, right? And it's basically, we want it to be systems that are scalable, that can be seamless. Then there's no need for us, human, especially coder, to worry about that. So we kind of delegate to agents. Maybe they are supposed to know how to handle scalability things, right? All of these things. So and then another thing, of course, too, in a lot of compute kind of when it comes to it, and it is something that I think in general too, developers have a tendency of saying, I'm going to implement this and it will work. But the truth of the matter is, things don't always work. So if things fail, we want agents. In this case, maybe there are agents that should know, right? Supposed to say, oh, I spotted something wrong, I go and fix it. So that's also another area that I don't feel is truly being like research into, or having examples saying that, well, an agent is supposed to be so intelligent that it can spot something and go fix it. And I think right now too, we still need to code it somehow, kind of prepare the agent to do things. So what I'm kind of trying to say is that in an ideal world, the agent's supposed to do everything and there won't be any human in the loop. But in reality, we know that there are still a lot of human in the loop, in processing. What is actually all these LLM and generative AI kind of advances to me right now, it saves us a lot of time in a lot of very tedious type of processing. A lot of things that we talk about RAG, which I'll talk in a little bit, right? Those are the kind of situations, use cases we can essentially make use of make use of LLM to kind of handle it. So, okay, so some more key concepts too, because I might talk a bit more architecture. So I was just wanting to talk about key concepts. So there are vertical architecture too. It's just like doing any kind of apps. And essentially too, when it comes to agent is essentially, to me, is also not new, right? And it's essentially saying that agent is very good at doing certain things. And essentially too, each agent is kind of responsible for some aspect of a complex kind of system. So vertical architecture would be meaning that we have one agent is like leading, being the leader, and making certain decisions and delegating tasks, and all of these things kind of gets into more agentic like orchestration. And then there are also architecture that's more about horizontal architecture, which means all agents are pretty much equal, kind of they have the equal amount of permission to do things, and it's multiple agents collaborating too. And then of course agentic orchestration, that's another aspect of what an agent can be doing, and also very complex type of task execution as well that agentic architecture is supposed to be doing. Autonomous decision making, just now I already talked about it, the reasoning, the planning, all of these things. And so that's where I kind of pull in the LLM to help to make decision. And then not only that too, one key aspect too of agents, as we all know, even pre-AI time, if you're studying about that, going deeper into computing, is basically the adaptability aspect too of agents too, able to get some be transformed, right? Certain situation that happens, it should know how to address and be transformed and adapt to new situation. So that's where I think the agentic architecture should also need to be able to address to that area. And basically, ultimately, is no human intervention. So then we can all relax, right? And then have agents do things. But the truth of the matter is, it's not there. We aren't really there yet, but we're making great strides in progress. So okay, let me then look into this a little bit deeper about event driven and data, right? So, at the heart of AI, we know that it's the data, as I'm kind of bringing this back. And data itself, right? We deal with also the flow of data in many directions too. So, working with data and tools. So, now, right, before event driven, let's say, right? What happened if you kind of look back even in the US, for example, right? And essentially, too, real-time computing became the thing. And also, like, I think during the 50s, 60s, when there were military kind of use cases in which they need real-time kind of processing. Now, back then, the computing was kind of older, so it's dealing with things a bit on the batch side, right? So to speak, yeah, you do things, you get data collected, and of course, we're still doing punch cards and all these things. But the thing is, though, for military, they're always ahead of time. So I think that's where the real-time aspect came into play. And so the thing is, real time, how can we enable that, right? Meaning that when data should happen and then we process it right away, that aspect. And so that's when like event driven architecture, event driven kind of approaches coming into play. And over the, all these, time periods, we see that data, we all recognize this as important, but for some reason, I feel especially programmers don't seem to, developers, right, tend not to kind of pay more attention because it's complex, it's messy. We don't like the compute part, but the thing is, we have to operate on all the data. So let me kind of look at it. So architecture level, there's event-driven type of architecture, meaning your whole system perhaps is kind of driven by data that's flowing through the system. It's kind of event-driven. What causes event is some kind of data changes, right? State, for example, things like that drives things to happen. So and also understanding too, data, it can also have different states too, and basically they can be at rest. And so like as in storage or inside a database or file systems, they are in at rest. Now the thing is, what makes it very useful is basically data has to be flowing again, right? There are changes state. For example, you place an order comes in as new status, and then somebody, a clerk, processing clerk, picks it up in the system. It becomes like in process, for example, like initial whatever it is, and then basically order can go into like inventory check state, whatever, right? So goes through these different things. So they are in use, right? So basically you select your order and then they are being in use and being manipulated, being transformed. And then of course too, there are data in transit too, is when, data, you need to send the data from one network nodes to another. We're getting kind of more sophisticated now. Is not just, taking the data out, operate, but we need to send the data. So that's when kind of there are techniques, for example, like event streaming, event messaging, all of these event sourcing, CQRS comes into play too. So streaming, for example, like the thing that we are already working with, maybe sometimes we don't think back, is basically streaming is dealing with many event like streams happening, many data flowing through the system, and we need to handle them. We need to log them. So that's when Apache Kafka or Apache Pulsar, that's the talk I did, I guess, 2 years ago here at the conference here. Basically, that time I was working more with event streaming, but not the AI part. And now with AI, I want to bring in streaming to AI. So Pulsar, and then also Red Panda or Solus, all of these are like event broker, all of these things that helps to, and also the messaging aspect. So streaming is more dealing with streams of data flowing through a system, but there's messaging that deals more with you sending from a source to a destination like that. So same thing. You can also be using tools such as on the Java side, Apache Kafka. Apache Pulsar is also still being used, but my understanding may be like less of, because it's a specific build, right, and all that. But Kafka is still kind of like in like being majority being used in a lot of companies as well, especially the enterprise. Red Panda, Solus, all of these. And then also I want to touch on like event sourcing and CQRS too. So if you are new to that, and just a quick kind of introduction to that is event sourcing is essentially we want to start to store data instead of, let's say, right, traditionally we have an order entry and there's a status column that tracks the change of state of this order. But the shortcoming of that is that if you just store the status in a column, then every time your change of your order, the status change, and you essentially overwrite the previous status. But then when it comes to recovery, if there are some issue, or even if it's just not issue, but just for observability kind of usages for tracking purposes, let's say I want to have a way to replay the order. And again, it kind of reflects on how fluid data is, right, for any kind of entities. So in that case, if you try to replay it, then it's kind of becomes very hard. I don't even know if it's possible. Maybe you can look into audit logs and kind of look into the change of status of an order, but it's harder. So that's when I think the kind of motivated this event sourcing kind of techniques that comes in. So what it is kind of like, Kafka is doing these logging that's what it is, messaging logging. So we're kind of logging the changes of an order that you are storing, right? And logging it whenever there's a state changes, you save that state. So then over time, you can kind of go back and say, okay, I want to see what is happening between 10:30 and 10:40. Especially I worked at trading environment too. You need to be able to see what is happening. We're seeing some discrepancy in the payout, whatever it is, right? Especially when it deals with money. So event sourcing can help in that sense. And then there are also like patterns that goes with it. It's CQRS, command query responsibility segregation is really the pattern that helps with, when you write the data and also the reading the data too. The patterns are separated, so then you make it very efficient. And you also want to do the read and the write, especially like writing into your storage in a very efficient manner. And then also when you go and retrieve it too, also can be very efficient too. So that's CQRS. Now we won't have time to get into all the details today, but just thought I bring this up here. So then getting back to generative AI streaming usages, right? So we're talking about Gen AI, and of course now we're talking about natural languages. We can be speaking into your some way of interfacing, right, a web page or like whatever it is, maybe on your app, on your phone, that type of stuff. So all those too. Also like streaming, there's no fixed time. I could be like asking a question at any time. So those things, the prompts too, are kind of a way you need to stream those what you call input into your system. So the prompts too, from different sources. And then also too, Gen AI also has intermediary steps too. Now, as we all know, LLM has its limitations. LLM, you cannot, it gets trained of data only under a certain period of time, right? And just say, even just an example, the first ChatGPT that came out in November 2022, it only got trained with data, that 3.5 version, right? It's only get trained until 2021. So then what do you do, right? That whole time during 2022 when it's being trained, and all the data didn't get kind of copied into the system. So that's another one example. And the other example is, what if I work for a company? I'm in a hospital. All of the data is not. I don't want to train it in the public sphere. So then it becomes kind of becoming no longer private in that case. So you want also to handle data that's in a private setting, a private institution. It's all behind the firewall, that type of stuff. And not only that, right, there's also need for, what if I have real-time data, I want to kind of get it in, so we kind of have the LLM kind of evaluates and get answers for me. All these kind of different kind of reasoning, that's when we actually need to have a new technique, which is in this case like a RAG. It becomes the de facto way techniques, right, of dealing with retrieval augmented generation to help to supply more context to the LLM. So, okay, so that's that too. We can also think of ways of leveraging an event streaming, event kind of messaging types of approach, right? You could be sending data to a Kafka topic that can be picked up and be processed as part of the RAG kind of operation. For example, and reading from a database, a private database, it doesn't expose to the outside world, that type of stuff. So these are kind of examples, and sending requests eventually to the LLM when a RAG application is ready. Now I'm going to present the question, the enhanced prompt with enhanced context to the LLM. So that's kind of streaming usages too. And then of course too, when the LLM finished processing, is going to send back data. So that's also too, responses can be streamed back to the requester too. Okay, as you kind of look at it too, right? The benefits of this event-driven approach, and of course, it requires different kind of setup. You do need to set up message queues, doing all the stuff. But there are benefits of doing that too. Basically, nature of data and its flow patterns, all of these things, and can be addressed using an event-driven approach. And also too, you can essentially enhance the communication to do things like asynchronously. There's no need to kind of block waiting for stuff, for example, and you can be handling through event streams. And also too, it should help with addressing issues in the scalability kind of aspect and flexibility, because now we're kind of looking at all of these components are loosely coupled type of components. Whoever is producing messages can be handled separately than the ones going to receive messages. So for this too, I'm kind of pointing out to, if you're using like a pub sub type of broker with a broker type of messaging systems, that it can help, because what happens is, if you need to scale up, then you can add more brokers. Sometimes one broker is overloaded. You can actually have distributed multiple brokers handle the receiving messages side, the producer side, as well as sending out, distributing messages to subscribers, that type of stuff. So those are the benefits too. And of course too, for agents too, in Gen AI types of usages, we're talking about agents too. You can be having agents that are handling maybe like text, to image type of translation, and another agent handling like video to text kind of thing. So you can have different agents handling different concerns of your system, and but yet they can all be working together, and also too, they can be tied together. All of the messaging can be implemented using this kind of streaming kind of approaches as well. However, the thing is though, with all of these event approach, while they are good, and also the thing is, they are not very easy to set up, not as easy, I should say, but it's just a little bit tricky. We have to also be concerned with the fact that it may be harder to debug, because now you're dealing with messages and all of these concern. How do you track it, all of these things? So just have to maybe do a bit of extra work to make sure there's still observability support to help too, especially when it comes time that you need to track and debug and all of these kind of things too. So, but it's like, I think it is a good approach for certain types of use cases. For example, like fraud detection. If we want to leverage on AI type of agents to help, and with that, right, having agents like monitoring something, essentially too, you can kind of think of using an event-driven approach. So now let me get into like distributed computing and agentic AI kind of data engineering side. So as we all know, if you are have been working more with data, you know that academically, right, we kind of talk about CAP theorem too. So the three fundamental aspects, right, of CAP theorem: consistency, availability, and partitions tolerance. So basically, this theorem is stating that only two of these three aspects are guaranteed. So what does it mean? So, as we all know, right, life used to be easy if we just do things on a single computer. There's no need to send data between different nodes and all of these things. But we live in a highly distributed world, and we rely on the network heavily too. So even just now, I'm doing my presentation. All of a sudden, network, went away, and we know partitions tolerance, right? Then that's what it's referring to. So basically, in that particular case too, you need to deal with network failure, connectivity issues, whatever the cause is. So essentially, it's basically saying that CAP theorem is basically saying that you can only have two. So you can either choose, if there are network issues, then essentially, what do you choose, right? Consistency or availability. Availability has to do with response. Yeah, you kind of making a query, all of a sudden network goes away, and do you wait, right? You want data to be the most updated too, but at that particular case, there's no network. Then basically, it can be you have to suffer. You know, the availability has to suffer. You wait for the network to come back, then you can get back, answers that are more consistent. That's the latest. All of these things. Now, at the same time, some systems, though, actually requires kind of availability first, meaning, I don't care if it's down, I need an answer. So in that particular case, if a network goes down, if you choose availability, you have to know that its consistency has to suffer. You're not going to get the latest update to when, system keeps going, you don't have the connection. So that type of stuff. Now, the thing is too, then it brings in another kind of thoughts too on availability. It is essentially eventual consistency will win, meaning that, eventually basically network comes back, then if you will get back the consistency. That just means you need to query the system again, or whatever, some mechanism that will send you back and say, hey, this what I sent you previously isn't the most updated, but is eventually it will be consistent when the network comes back. So this is just a diagram too. Then when I was kind of searching to see, give an example, and you might be asking, why is it important? Because there are certain vendors designing the databases, and they have certain kinds of criteria too. So you just have to understand, first of all, now it gets to more designing your application, your solution. If your kind of application requires more consistency, you always want to have the latest kind of data. So what kind of database might be good? So over here too, basically the consistency, you can see that these three kind of aspects. So if it is more important that availability, then you kind of look underneath here. There's a DynamoDB or Cassandra, Voldemort, React, and also like CouchDB. These are more availability comes first too. So even if it's kind of network failure, you know that you always get back results too. Whereas if you want something more consistent, more like it might be less responsive, so to speak. But for example, like HBase, Google Bigtable, MongoDB, all of Redis and Hypertable, they kind of favor more on the consistency side too. So in the event of like network failure, it may not give you back results, but it will, whatever, when network comes back, it will give back more consistent result. And there are also like Oracle database used to be more consistency, but I think they are now kind of moving towards more of availability, all of these things too. So on that right hand side is the kind of database you should consider if consistency, availability is more kind of urgent for you too. So okay. Now, then it kind of moves into the next thing, which is Parcel. So this one stands for partition tolerance, availability, consistency. Else, there's latency and consistency. So essentially, it's saying that cap theorem is one thing, but in reality too, even without partitions concern, we still need to choose between consistency and availability. So that's what this parcel is too. So so it's kind of an interesting thing. So you still need to choose between, is it latency important, or is it like consistency being more important without the concern of network partitions too. So basically, now it comes back to the Gen AI of this talk, and it's a bit more about Gen AI kind of workflow. So basically, if there is a partition issue, well, we choose availability or consistency, right? Cap theorem. But in the absence of partitions concern, you still need to trade, latency versus consistency. Now, for Gen AI types of application, it's basically the belief is that the else part dominates, meaning that users in a Gen AI type of application, when there's like so much data flowing around, we expect these streaming tokens in less than 1 to 2 seconds too. So then it pushes you towards like low latency reads too. So and basically we are relying on eventual or session consistency. So that's kind of Gen AI type of situation too. And because also in my kind of thinking about it, that theory, that kind of thought process makes sense, because if you kind of think of Gen AI itself is relying on LLM itself too may not actually be too consistent anyway. So, which means the way I'm looking at Gen AI perhaps is more suited to doing things like, with imaging, with video, even if your some pixels is off, right? Little things like that. That kind of data isn't going to affect your overall outcome. However, if you're dealing with financial applications, some kind of, a healthcare kind of devices and that kind of stuff, maybe that's actually you have to think about it. Consistency is probably more important. You want data to be more consistent in that case. But I think still there's a lot of trade-off when we're working with LLM essentially. But there are also like different techniques now to try to address that aspect to kind of make hallucinations be less of a concern in that case. So so that's it. Let me kind of move on to the next thing now. CQRS and agentic AI too. So just kind of a bit of a word to kind of emphasize that is command query responsibility segregation too. So already I kind of mentioned too, it separates out the data model being used for writing is the commands, and then also reading is the queries too. So this is important to know, especially let's say we start more into more serious agentic application for distributed kind of data scenario. This impacts the data storage requirements too. But the thing is, though, with CQRS, I do believe that it's probably agentic AI systems is going to be, for the serious type of agentic I'm talking about, when it deals with end-to-end enterprise level, we need to concern with concurrency, with distributed data. Perhaps like CQRS would be a good technique to employ for agentic AI types of scenario too. So maybe in my live stream, I'm going to start exploring into actually implementing a couple of kind of examples to handle CQRS too. So just stay tuned. Now, I'll just get into RAG too, just really quickly for those in the audience, perhaps. May need a bit of a refresher. So RAG is retrieval augmented generation, and it's a hybrid framework that integrates the two components of the model. One is the retrieval model, the other is the generative model. The goal though of retrieval augmented generation is that ultimately why RAG is because we want to pull in the most updated data, also supposedly more kind of what you call like that's real-time data, then also in some cases like private data sets that's not exposed to the outside, all of these things. But the ultimate kind of goal is to be able to produce text or kind of output that's not only accurate, but it's also it need to be more information rich too. So that's kind of RAG too. Okay, so let me go to the next one. And so just a real quick thing explaining RAG application. So when let's see. I'm sorry, I think somebody is saying that you can't see the slides. Is that right? Okay, I don't know. Louis is okay? Yeah, okay. If well, I can see from mine. So if there's problem, we can take a look, right? Yeah.
I think we're seeing the same slide for some time, like benefits of the event-driven approach.
Oh, really? That is weird. Because here, you and I, we can see it. Okay, that's what Vincent was saying, and I'm sorry about that. We have already switched it. I'm not sure. Uh, it could be maybe I'm on the 4G 5G network. I'm on the RAG now. Okay, let me see. I think RAG. Okay, RAG slide. Okay.
And we can try remove it and maybe share it again.
Oh, you mean that we send? Okay, remove it from the screen and share it. Okay, let me share again. Uh, okay, let me out of screen and then I can share it again. Right? Sorry about that. All of this issue with this. Okay, is it Louis? You and I we can see. Reset the
Yes,
display. Sorry.
I think
How
that's
do
right,
I?
right now.
Yeah, we're good. Okay, all right then. No PB. Perfect. Okay. Okay, good. I am sorry. Okay, I know it's a time is running short, so let me real quickly kind of explain, right? Now this reg is a bit of a higher level. I don't go into all the details of, for example, chunking, all of these things. So we're just assuming in a perfect state, right? Just explaining this kind of flow. It's basically right. The end user is going to send a prompt in, and the reg application will then take this prompt and also do some sort of semantic search to a vector database, something that's backing, because it's going to retrieve more relevant context, right, from the vector store. And then with that, together with that, then it will combine, the reg application will combine and send this prompt and relevant context, essentially an enhanced context and in the form of the prompt to the LLM, and then receives response. So that's kind of essentially how reg application would work. Now you can also kind of like replace this in terms of, instead of retrieving from a vector database, it can be from a Kafka topic, from even from a socket too, if you're kind of into that level of detail too, right? So okay, okay, so that's that. So I just want to kind of show this because essentially too, this is demonstrating the role of the retrieval model. So in a nutshell, right, this retrieval model is like a librarian. It's going to pull in relevant information from that database or corpus of documents, or from a stream of these things, whatever the source is. So that's the responsibility of the retrieval model. It package up and doing like an enhanced prompt. Now, again, I'm kind of hiding all the details because in a lot of cases, right, say for example, a big legal firm, I have 10 years worth of court cases that are in very much detail. Then in that particular case, we know that one cent is not going to do it, because it's just simply the LLM, you run out, there's a bandwidth to handle all the data. So one of such techniques is called chunking, right? So chunking will break it up, your whole set of documents, into some kind of logical kind of partitioning. Now that's another level of techniques that I won't get into all the detail, but I believe there are some talks that gets into all the details. How should you divide up, right? Where do you do the beginning chunk, end chunk, and how big the size and how they overlap will affect the results of your query as well. So that's kind of very important. But the thing is, that's also responsibility of on the retrieval model side, right, in a high level. So now, then it comes to generative model. Let's say reg is done. I send my request over to the LLM in an enhanced kind of prompt, and if LLM eventually will come back, look at all the data, comes back with all of these things and sends back. Now, before it gets sent back to the requester, there's the retrieval model side. Generative model. So generative model will take this and essentially to kind of massage it and basically enhance this responses, making it even contextually rich, also semantically too, also kind of very nice, right? And that's why too we like to ask LLM write the article for me, because it's supposed to, right? No, most of the time actually it does, and kind of produce very kind of eloquent kind of sentences to kind of help us too. So that's kind of a retrieval model side. So just wanted to kind of bring this up because there's also a lot of event streaming that can happen during these communication too, when it's kind of crossing boundaries into the different kind of function of this system. So now let me then get into a bit more of the agents and agentic too. So again, agents, its role is it's authorized to act on the behalf of another, right? So to do things. And so when it comes to AI, meaning that I'm handling AI types of operations, agents and agentic, all of these things. To me, I kind of again have to say the marketplace is kind of full of all these marketing terms, and it's just making it even more confusing. But the thing is, as developers, I think I really love working, staying, even though these days I'm less of coding, but I come from more software engineering. I just love it because we want precision, we want accuracy. We are very down to earth people. So okay, so what we're doing, right, in Gen AI agents is we help with orchestrating complex workflows. We coordinate activities of multiple agents and process logic and evaluate answers. So these are kind of the role of the agents, a responsibility. So most of the time too, I think if we kind of, especially if you're in IT department of a good size company, banks, or all these things, even hospital, we probably will be employing multi-agentic systems, meaning that we have autonomous agents. They are each autonomous, but they need to work together too. And each one of them specialize in different tasks, right? So it's essentially we also have to kind of have agents being able to help each other out. So I think that's also another kind of thing I think we should strive for. It's like sometimes agents is acting on behalf of us, and we also too, if we need questions to be answered, we go to another person and ask for help too. So that's kind of the idea of multi-agentic systems too. So now, let me also get into the next thing, and it's more about protocol, and I believe some of you are already been working with it as MCP. Is essentially too what happened is that you can be like having some kind of tool integration working with N8N, something like that, like a workflow stuff. But the thing is too, you can have different agents kind of handling with different, like, essentially backend and resources. So we need some ways of kind of standardizing the interfaces, and Anthropic came out with this MCP. It's catching on like fire. A lot of people are doing things. There are also a lot of free tools people are sharing on the on like GitHub, or kind of sites that you can actually get MCP server, MCP client, and it does require the client. It's basically described as a USB-C kind of interface, kind of socket. So you can basically plug in different, kind of outlet to do different things as long as the interface is the same. So the MCP is essentially functions like that. And then there are also another protocol, A2A. So A2A comes from Google. So the thing is, the difference is that at first too, when I look at it, when Google came out in July or June last year, it's basically I thought, oh, that's another protocol. It's confusing, all that stuff. But as I found out too, A2A is dealing more with between agents. How do you do the messaging? Whereas MCP deals a bit more with the lower level, deals with the API, the enterprise application, talking to different resources. So that's why they both kind of work in close collaboration with one another. That's what the design is. Now, I also have a couple things I want to discuss, but I have to apologize because I need to be hosting Bruno in the next session. But I do want to share with you this slide deck and also invite you to join my live stream. I do intend to have some live example in my live stream as well, but I do want to also point out too, there's agentic pattern to do things. Now, AutoGen from Microsoft is a free SDK for doing agents, and the AutoGen is good for building chat kind of bots too. So I also share with you the link to the archive.org, the research paper that they have this with that, and then also agentic design patterns, reflection tool use, planning, and multi-agent collaboration can also be found. I have shared these papers too. It's by Dr. Andrew Ng. He's the one that leads the deep learning.ai. It's got some very interesting concepts in there as well. And there are also orchestrator design patterns too, which is also very interesting. Here, I'm just highlighting some orchestrator worker, hierarchical agent, Blackboard, and market-based type of different design patterns. So, and invite you to join me next time, and because I probably have to get going pretty soon. But there's a reflection is actually quite interesting. I want to point out is essentially now the question also always come up to is agents is going to be asking the LLM to do work, but how do we know it is correct, right? So that's the reflection pattern. I think it's a common pattern now being used. That's what you can do is have agents keep querying multiple times, and we believe that the more you ask the LLM to correct, then eventually after so many evaluation, and also too we are using also a critic or eval agent to be checking the accuracy of the coder agent in this particular case. You do it multiple times, so it's a reflection type of pattern. Then we should be able to obtain a more accurate result and reduce like hallucination. So that's the kind of thing. So okay, so the tool use, another thing, and also Crew AI. I have a couple things. So I'm going to share with you. And also, this multi agentic collaboration is more of a research project, too. I've shared with you that article. So if you're interested, please take a look. So okay, all right then. And also too, I wanted to point out there's a Java and AI workflow that I found out and here in GitHub. So if you are interested for Java folks, you can kind of take a look too. And I have to kind of apologize, but wanting to say there are challenges, making sure that if you're doing Gen AI types of application, it's not as simple as we thought. Something, well, of course, you can rely on all of the tools, but if we're talking a bit deeper into distributed data, we need to kind of be concerned. And AI safety, responsibility, accuracy, and protection of all the data as used by agents too. So with that, I just want to quickly share. This is the slide deck, and I will also share it with. I think this you can also always search it, but I don't know. I think on the Java Champion site, maybe there's some way we'll be sharing. If not, you can always look back at the recording and find this link too. So, and then also some of the links too. I also have an article on the Java Advent calendar that was last year. If you're interested in reading that, some example code, and my stream too. I talk about my Twitch stream and my YouTube stream. And with that, I want to thank you so much, and please keep in touch. And thank you all for your support and for your patience and being so forgiving. And thank you so much. And I look forward to seeing all of you at a conference somewhere. Thank you. Thank you so much, Louis, too, for hosting. So.
Thank you so much for this incredible presentation. I hope everyone enjoyed it as much as I did. And we don't have time for questions, but thank you so much. Thank you, everyone.
Thank you.
See you in the next session.
Okay.
Bye-bye.
Bye-bye.